Okay, so I'm going to do one example here for finding out final velocity. So final. So how about we'll do question number 24, because once you get to 26, you have to do problems 22 to 24, calculate the final velocity of each projectile. So I'll go back to 24 here, and we'll just solve this as far as we need to in order to figure out final velocity. So what does this look like? A pitcher throws a baseball at 140 kilometers per hour if the plate is 28.3 meters away. So it's going to be a situation where it's a lot like throwing something horizontally off of a cliff. So in this case, the pitcher is at some height because of the pitcher's height, and also in baseball you stand on a pitcher's mound. So this is thrown horizontally, and it travels in this projectile motion like this, and so this is where the baseball plate is. So if it's thrown originally at 140 kilometers per hour, this would be our Vx. So at the very beginning, it's going to be taking off at 140 kilometers per hour, and if we divide that by 3.6, then we would get what was it, 38.8 repeating. So it's a good idea to put that piece into memory. So, I'm gonna on my calculator put that into memory, and I will put this here for Vx 38.8 repeating, and that is in meters per second. Don't have quite enough room there. So this 28.3 meters away refers to this horizontal displacement. This is that 28.3 meters. So looking over here, I'll put a 28.3 meters. Okay, so along the way, this Vx, the 140, that arrow, stays constant. It's a constant Vx all the way around. So if I was to draw a bunch of arrows, that is still 38.8 at the very end. This is my initial. Here, this would be my initial point that I'm interested in, and this would be my final point that I'm interested in. So I'm talking about final velocity. What's the velocity at the very end here? So clearly the Vx part is 38.8. Here, I'll just erase that and just label that as Vx. But it is also now going vertically. So when I'm thinking about the vertical velocity, at the beginning it's 0, and then it's going down a little bit, and then later it's increasing. Right, like this, and at the end it's got a pretty significant Vy. So this is what the vertical velocity looks like. I will say Vy2 here for final vertical velocity. So what I need to do is find out what Vx is and what Vy is, and then my V, my final velocity, would be the sum of these two. So I could do it like this. Or what I usually draw is I draw my Vy2 over here, and then I have a triangle that I can solve for. So when I have Vx and I have Vy2, now I can solve for my V at the very end, and I'll figure out that side of that triangle and also figure out this angle. So in order to do our work here, I need to find out Vx, and I've got my Vx already, and the other thing I need to know is what Vy2 is. So looking at my kind of horizontal and my vertical. Horizontal, I've only got these three to work with. Vertical, I got my big 5 to work with. I need to figure out what Vy2 is. So what are the different things that we know in this question? Well, I think we know that Vy1 is equal to 0, because my initial motion is only vertical, and I know my Ay is negative 9.8. And I need to figure out what Vy2 is. Oh, I made a mistake. This should be delta dy, not delta dx. So I don't know how far it dropped, but what I'm going to do is on my left hand side I know two of the things, so I can figure out how much time it is. Once I figure out how much time it is, it's going to be the same time here. Once I've got that, then I've got 1, 2, 3 things, and I can figure out a third using one of my kinematic equations. So thinking about my x direction here, in x it's v equals delta d over delta d. My constant velocity formula is what I'm going to use, but I'm going to solve for time. So I'm going to get time is going to be equal to delta d over v, and since I'm talking about the x direction, those are my x's. So it's going to be this 28.3 divided by my 38.8 repeating. And so I get a time of, I think it's 0.7277 seconds, and that's what I'll put over here, 0.7277 seconds. So that's how long it's in the air. Now I can think about, oh, well, which of my 5 kinematic things does not have delta D in it? The one, it's actually kind of a nice one, so of our big 5, I'm going to use equation number 4, which is V2 is equal to V1 plus A delta T. Now, since I'm talking about in the y direction, it's going to be Vy2 equals Vy1 plus Ay delta T. Vy1 is equal to 0, so this is going to disappear right away. And so my Vy2 is going to be equal to negative 9.8 multiplied by this time, which was 0.7277. And my Vy2 then is negative 7.1316. All right, so I can fill this in over here. So negative 7.13 meters per second. Okay, so we're almost done. Now I know what Vx is and I know what Vy is. So here maybe I'll draw this again over here. So I've got my Vx figured out. Here's my Vx. And I know what my final vertical velocity is. Vy2 is going to be equal to. And so now I need to figure out what is this velocity side and what is this angle side. So again, it's just going to be our Pythagoras. So V is going to be equal to the square root of Vx squared plus Vy2 squared. When I plug in all the numbers, I think I end up getting 39.5 meters per second. And when I do the angle, again, remember it's going to be the inverse tan of my y over my x, Vy2 over Vx, and Vy2 is negative. I want to put those in as positive values just like I did before, and I think in this one I get 10.4 degrees. And then it would be time to actually make our statement for what our final answer is. So I would say the final velocity would be 39.5 meters per second. Now I think the textbook would say something like right 10.4 degrees down. I like to say at 10.4 degrees below the horizontal. But the way the textbook has it would be fine as well. So that's how you do that kind of question. I hope that was helpful.